Hey guys, I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In this video, we will be discussing about the largely available form of non-conventional source of energy, and that is ocean energy. So let's get started. Well, in a life, you must have come across this fact that around 70% of Earth's surface is being covered by only water bodies, either in the form of ocean or in the form of rivers. So, this holds a huge amount of energy potential that can be converted into more useful form of energy such as electricity. Ocean energy is so vast that we need to divide it into three parts. One is the ocean thermal energy, next is tidal energy, and lastly we have ocean wave energy. We will understand them one by one, starting with ocean thermal energy. Well, in an introduction part, we have briefly described this ocean thermal energy as indirect form of solar energy. It is a fact that upper surface of ocean receives solar radiation. Hence, it is warm in nature. While the deeper water of ocean does not receive any kind of solar radiation. Hence, it is cold in nature. So, we can always utilize this temperature difference to generate electricity by means of turbine and generator assembly. Since the collection and storage of solar energy is free with ocean, the large surface of ocean collects solar radiation and store it in the form of heat so that we can utilize this heat and produce electricity. Well, to do so, there are two different methods which converts this ocean energy into electrical energy, and they are open cycle ocean thermal energy conversion system and closed cycle ocean thermal energy conversion system. So let's see open cycle OTEC system first. Well, the open cycle OTEC system utilizes surface warm water as its working fluid. This fluid is then sent to evaporator section where we produce steam out of it. It runs the turbine and produce electricity. Here in this image you can see that the upper surface water of ocean is admitted into evaporator where we maintain pressure below atmospheric condition by means of vacuum pump so that this warm water converts into saturated steam, and this product of evaporator is then sent to separator section where we separate this saturated steam from water, and this low pressure steam is then sent to turbine section where it drives the turbine and rotates generator shaft. Now we very well know once the generator shaft is rotated, it cuts the magnetic field and produce electric current. This electric current can be utilized for many purposes. This steam is then sent to direct condenser where we utilize the deeper cold water of ocean to convert steam into liquid. Then this liquid is discarded into ocean. So this is how we can convert ocean energy into electrical energy. Well, there is no need of heat exchanger in evaporator section. So open cycle ocean thermal energy conversion system does not require any kind of heat exchanger. That ultimately minimize the biofouling problem associated with heat exchanger. Here in open cycle OTEC system, low pressure steam is generated and hence the larger size of turbine is required, which ultimately increases the size of entire ocean energy conversion system. Lastly, an open cycle OTEC system must have degasifier within it to remove the gases dissolved in seawater. Now let's see how one typical closed cycle OTEC system works. Well, closed cycle OTC system involves separate working fluid which receive heat from source and reject heat to the sink. For this purpose, the working fluid must be volatile in nature. Gases such as ammonia, propane, and sometimes freon are uses for this application. They are easily converted from liquid to vapor and vapor to liquid. So, we utilize such volatile substance in this closed cycle OTEC system. Here in this animation, you can see that the warm water of ocean exchanges heat with ammonia in typical heat exchanger so that this ammonia gets converted into vapor form since it has volatile in nature. This vapor of ammonia is then allowed to go in turbine section where it drives the turbine and rotates the generator, and generator produces electricity in usual manner. So this is how we can produce electricity by means of closed cycle OTEC system. Well, this vapor form of ammonia is then sent to an condenser where it utilizes the deeper cold water of ocean and convert back into liquid state. So we can repeat the cycle and produce electricity continuously. So this is how we can produce electricity by means of ocean energy by open cycle and closed cycle OTEC system. Now let's move to the next type of ocean energy, and that is tidal energy. Well, you must have noticed that during some part of the day, the water of ocean start falling down, and during some part of the day, this water rises again. This phenomena is known as tides. Tides caused due to gravitational pull of moon and sun on the water bodies of earth. The huge up and down moment of water bodies on the ocean holds great amount of energy. So we can always utilize this energy to get some useful form of energy. Well, the main feature of tidal energy is the altitude difference between water level during high tide and low tide. We can rotate turbine and generator in order to produce electricity by means of this elevation difference of water. So let's understand how we can convert or how we can harness this tidal energy. But before understanding that, let's understand what are the different components of typical tidal power plant. Well, here in this image, you can see that a typical tidal energy power plant contains three main components that are dam or barrage. Second one is gate and sluiceway, and the last one is the powerhouse. So let's understand what is dam. Well, this dam kind of structure is being created to separate water of ocean from the water of basin. This dam act as a barrier for the water flow. Small length of dam is preferred since it involves large cost of construction, which ultimately increases the cost of entire tidal energy power plant. This dam or barrage section has to provide channel for powerhouse and sluiceway so that water can flow through it. Now let's move to the second component of typical tidal energy power plant, and that is gates and sluiceway. Well, gates are used to control the flow of water either from ocean to the basin or from basin to the ocean. So by means of gate, we can always control the flow of water so that these gates are need to be very rapid in action and consumes lesser power. Well, these gates are always submerged into ocean water, so we must provide protection from corrosion. This sluiceway provides passage for a water to flow so that we can facilitate the water of ocean or basin through this sluiceway. Now, the last component of typical tidal energy power plant, that is the powerhouse. This powerhouse basically contains two main components. One is the turbine and which is followed by generator section. These both are connected by coupling assembly in usual manner. So in this video we have introduced the ocean energy and defined ocean thermal energy, and we have seen some typical methods that are very important for exam point of view, such as open cycle OTEC system and closed cycle OTEC system to convert this ocean energy into electrical energy. In the next video, we will understand how we can convert this tidal energy into more useful form of energy. Till then, keep watching, keep learning. Thank you.